Okay, I'm going to share the screen. তুমি mute করে দাও. Okay. Now, today we will be designing from NOT gate. At first, we will design a NOT gate first. Okay. What is a NOT gate? So you have to understand. This is your NOT gate. At first, let's draw. This is a NOT gate, right? So if you give A, your answer will be A bar. We all know it, right? A is equal to A bar. Remember, see this thing. A is equal to A bar. That means if you give 1, your output will be 0. If you give 0, your output will be 1. That is the purpose of NOT gate. We all know it, but we do not know how this NOT gate is made. Okay, with what your NOT gate is made of. We do not know it, so we'll design it first. Okay, let's see. Now your design, your NOT gate comply is okay. You need one NMOS first, then you need a PMOS, an NMOS and a PMOS. So what I am doing, I am actually removing all the writings there because I will write them manually. So I need to connect. Okay, by the way, let's give the pin names. Okay, pin names. This one. So here you have source, gate, and drain. Then you have drain, gate, source. In case of PMOS, the source will go up. In case of NMOS, the drain will go up. So you understand what are these, right? These are actually N MOSFET and P MOSFET. Understood? This is the P MOSFET. Why we give a bubble in the gate of PMOS to make you understand this is a PMOS. That's why. We already know what is the working principle of NMOS, how NMOS works. We have seen a video at the very first class how NMOS works. So PMOS exactly works oppositely of our NMOS. Now we need to connect the gates together. We need to connect the drain together. That is the only rule. Then we have to connect the ground after the source of NMOS. Then we need to connect the VDD. VDD means 5 volt. Let's connect. Let's connect. So our input will be this one. This is our input. And our output will be this one. This is our output. See, this is the this is the NOT gate we are talking. So this will be A. This will be our Y. This is the NOT gate that we were talking about earlier at the beginning of our class. So let's see how this thing works. If I run the simulation, you will see when the input is 0, our output is 1. When our input is 1, output is 0. So how this is happening? So when your input is 0, that means this 0 is going to the gate of PMOS and going to the gate of NMOS. At 0, your NMOS is off. But when it is 0, that time your PMOS is on, because PMOS and NMOS, they are complementary. They work oppositely to each other. So when NMOS is on, that time PMOS is off. When NMOS is off, that time PMOS is on. Since at 0, your NMOS is always off, that means your PMOS is always on. So here what is happening? You have given 0, that means the PMOS is on. So current from VDD, that means 5 volt. From this 5 volt, current will come, current will come, current will come, and after that, current wants to go to the ground, right? Because when current comes from the battery, it wants to go to the ground as quickly as possible. So here, there is one ground at the bottom, but the current cannot go to the ground because this circuit is open. It cannot go in this way because this circuit is open circuit. Okay, so if it is open circuit, it cannot go, but it has to go somewhere, somehow. So what it will do, it will go to the LED, inside of the LED, then it will come out, it will go to the ground now. So current will come in this way, it will go through the LED, then to the ground. So when the current goes through the LED lights up. That means it is 1. So when your input is 0, your output is 1. So now let's see when your input is 1. When your input is 1, at 1, your NMOS is on. On means short, right? Your NMOS is on, but your PMOS is off. Off means open. Off means open. It is open. So when it is open, no current can come. No current. If there is no current, so there will be no LED. So there will be no on LED, right? So again, what is happening here? At one pin of LED, at one pin, there is a ground. In another pin of LED, there is also a ground. Can you see that? This ground is connected directly to the one pin of LED. Another pin is already grounded. So your LED has two grounds in its two pins. Okay, so that means your LED is off. So what we have seen, when your input is 1, your output is 0. When your input is 0, your output is 1. That means your A should be A bar. Okay, so that is a NOT gate. That is exactly what your NOT gate does. Okay, now why we are calling this thing CMOS? Because CMOS is the combination of one NMOS and one PMOS. Listen to this carefully. One CMOS means one combination of one NMOS and one PMOS. When one NMOS is connected with one PMOS, okay, that means gate is connected to gate, drain is connected to drain. If you connect it like that, that time that will be called, the combination will be called CMOS. CMOS, the full meaning means complementary metal oxide semiconductor field defect transistor. That means complementary MOSFET. Complementary means one is connected to another, but they work oppositely, like phone and charger. Okay, phone and charger, right? Phone and charger, they are completely different thing, but they do not work, they cannot work without another. Because if you do not have a charger in your phone will be useless. If you do not have a phone, your charger is useless. Understand? So that's why when you make them a pair, they will work fine. When not, they do not. So in case of our logic circuit design, CMOS is a must, and CMOS should be connected, and CMOS, that means your NMOS and PMOS should be connected, make a CMOS. So here you have one CMOS, and one CMOS means one NOT gate. Understand? Now let's okay, let's save it first because we need to save it. I'm going to make a new folder. Let's write D25. Inside the folder, I will write not. Now I will be designing NAND gate. NAND. At first, I will be designing NAND gate. So how I am going to do that? See, I'm going to disconnect all the connections. Okay, our design is complete. Before going to the operation, let's discuss what is a Nand gate. Okay, so what is a Nand gate? Nand gate is actually this one. This is an AND gate, but Nand gate is the opposite one. Opposite means you need a bubble. So here you have A, here you have A, B, not A bar, B. Here you have A, here you have B. So your output is equal to Y. So your Y must be equal to AB bar. So this bar is important. Remember, this bar is very important. Okay, let's use this part. Let's write it nicely. Here you have AB bar. Okay, so A into B bar. So your NAND gate is actually multiplying things and inverting that. Okay, AB bar. Your AND gate is A into B. This multiplication thing is very important. Remember the word, I am multiplying things, right? In NAND gate, your inputs are multiplied. Your inputs are multiplied. Then you have a bar. Previously, the design with CMOS that has a bar, A become A bar. Now AB become AB bar. Okay. So CMOS, whatever you are going to design, everything will have a bar. Everything, whatever you are going to design using CMOS, everything will have a bar by default. This word, mark this word. Remember this word. Whenever you are going to design something using CMOS, everything, whatever you design, everything will have a bar by default. So if you want to remove the bar, or if you do not want that bar, you have to remove it manually. Okay, you have to remove it manually. Otherwise, whatever you are designing, everything will have a bar. Okay, so here what is happening, here you have two PMOS and two NMOS. That means actually they are forming two CMOS. This one is for A because it is connected to A. Can you see that? It is connected to A. This one is also connected to A. So this one and this one, they are actually pair. This one and this one, these two are a pair. Okay, this one and this one. So they are making one CMOS. This one and this one, they are another pair. So they are actually making a CMOS. How can I say it is a pair? Because their gates are connected. Can you see the gate? This one is connected to B. This one is also connected to B. So two inputs, that means two pair. For one input, you need one pair, that is one CMOS, that means one NMOS, one PMOS. For another input, you need another pair, that means another CMOS, that means one NMOS, one PMOS, like that. One PMOS, one NMOS, like that. So you need, for two input, you need two PMOS, two NMOS, and your output will be always one, because we know the gates has only one output. We know it already. So let's see how they works. I'm going to run the simulation. Now see, when your, what is that? When your inputs are 0, 0, that time, okay, let's write it here. 0, 0, your output is equal to 1. So here you have A, here you have B, here you have Y. When your inputs are 0, 0, both of them are 0, 0. So what will happen? Your output is 1. Okay. Now let's change the input 0, 1. When it is 0, 1, you can see your output is still 1. Okay, let's write 0, 1. So your output is still 1. Let's write 1, 0. So let's write 1, 1. and check whether what is our output. And let's check whether the output changes or not. So okay, now we will be doing 1 0. Still your output is 1, right? So I'm going to write 1. I'm checking, now I'm giving 1 1. So whenever I give 1 1, your output is 0. So for 0 0 it is 1, for 0 1 it is 1, for 1 0 it is 1, for 1 1 it is 0. So as you can see, this is the truth table of Nand Gate. Truth table of Nand Gate. So I am not talking rubbish. I'm actually having the proof. It is a Nand Gate, right? So this is how you actually make circuits. So when you have a truth table and you make a circuit that actually gives you the same output, that will be your design. So here, this design is actually your Nand Gate. Nand Gate means this is actually your this design. So if you take one Nand Gate and that has two inputs, one is A, another one is B, and you have one output that is your Y. This is actually this one. So inside the Nand Gate, you have these. You have 4 transistors. 2 of them are PMOS, 2 of them are NMOS, and they are connected such a way so that they form a CMOS. Okay. Now, let's see how it works. Why they are giving you at 0 0, why they are 1. Let's discuss about that. Now, whenever they the inputs are 0 0, that means the both of them are NMOS are off, because at 0 it is off. It is off, right? Okay, let's write something. So when it is 0, that means this is 0. This is also 0. This is 0. This is also 0. So at 0, your NMOS is actually what? Off. Your NMOS is off, but your PMOS is on, right? Your PMOS is on. So what is happening? A current will come from the VDD. That after that, it has two ways to go to the ground. One way will be this one. Another way will be this one. So your current can come and follow this way, or it can come and follow this way. Actually, the current will be divided into 2 ways because of the Kirchhoff current law. Current law has said that if your current goes to a point that has two ways to go, it will be divided. So it will be divided and it will go through the both MOSFETs. Then after that, they will be reunited again. When they come at this point, that time it will see the way to the ground is off. There is no way by which it can go to the ground, right? That time it will follow the output part. So it will go to the LED, then it will go to the ground. So when the current goes through the LED to the ground, LED is on. Understand? That means when you have 0 0, PMOS are on, NMOS are off. So current can only come to the midpoint. After that, it cannot go to the ground because the paths are off. That time it will go through the LED and go to the ground. That's it. তার মানে হচ্ছে যারা বাঙালি তাদের জন্য বলি, কারেন্ট আসবে, তারা মসফেট দিয়ে মানে পিমস দিয়ে যাবে, গিয়ে তারা মাঝপথে এসে দেখবে যাদের এনমস গুলো অফ, সো ইট ক্যান নট গো, এটা যেতে পারবে না, তখন তারা এলইডি এর মধ্য দিয়ে গিয়ে তারা হচ্ছে গ্রাউন্ডে চলে যাবে। So by that time the LED will be on. That means your output is 1. For 0 0, your output is 1. Now let's try the next combination, 0 1. When it is 0 1, that time you can see your one MOSFET is on because its input is 0. So its NMOS is 0 as well. this one is 1. So its NMOS is also 1 because they are actually common. So at 1, the PMOS is off. You can see, right? At 1, your NMOS is on. You can see it. At 0, your PMOS is on, right? You can see at 0, your NMOS is off. So this is off. So what will happen? So current will come. It will not be divided because this way is no longer valid. Okay, this is off. So it has only one way. So it will go in this way. It will go in this way. It will come, right? Then it cannot go to the ground because this is off. One path is broken. This path is broken. It cannot go. So it has to go in this way through the LED, then to the ground. So your LED will be on, your output is 1. That's it. Now, so that's why when you give 0, 1, your output is 1. Now let's try 1, 0. Now when you do 1, 0, what will happen? This is 1, this is 1, this is 0, this is 0. Okay? So what is happening? At 0, it is on, you already know it. At 1, this is off. At 1, this is on. At 0, this is off, right? So what is happening here? What will happen? See, a current will come. Now it cannot go in both ways because this way is off. So it has to go in this way. Then it will go here, it will go there, it will go there, it will come here. After that, it cannot go to the ground because this way is broken. So what it will do? It will go through the LED, then it will go to the ground. So by that moment, your LED is on, that means your output is 1. So for next part, your both of the input will be 1. So this is 1, this is 1, this is 1, this is 1. So no current can come because this is off, this is off. So if there is no current, obviously your LED is off. And again, one more logic will be your LED has 2 ground now. One ground is already connected. That means this one. Another ground is connected through this point. See, your ground is short. Your ground is short at this point. So at this point, you have one ground, that is this one. And the other pin, it has already a ground, right? So both of them are ground and ground. So LED is off. For 1, 1, your LED is off. That means 0. So you have understood, right? I'm taking some feedback now. Stop sharing. Are you understanding?
Yes, sir.
Yes, sir. Yes.
Okay. আচ্ছা আমি একটু আমার রেকর্ডিংটা পজ করি। Resume. Nothing. We just need one more inputs, right? One more input. So what do you have to do? We have to take the input and we have to replicate it. This will be our C. Let's make it smaller. Take that at the bottom. make a copy of this one. Okay, make a copy of this one. Take that here. Here. Connect. Connect. And this will be C. That's it actually. So you have three inputs, right? So A, B, C, they will be there. For one input, you have one PMOS, one NMOS, another one PMOS, one NMOS, another one PMOS, one NMOS. PMOS will be in parallel, NMOS will be in series. That's it. So since you had one input, when you had one input, that time you have one PMOS, one NMOS, two inputs. So you have two PMOS, both of them will be parallel, and NMOS, they will be in series. Why they are in parallel and series? This has a rule. Okay, I will let you understand later. When you have three inputs, that time you will have three PMOS and three NMOS. That's it. Now, I understand this looks very okay. Let's see the what is that truth table first. When you have 0, 0, 0, you have 1. 0, 0, 1, you have 1. 0, 1, 0, you have 1. When you have 0, 1, 1, you have 1. When you have 1, 0, 0, you have 1. 1, 0, 1, 1. 1, 1, 0, 1. When you have 1, 1, 1, that time you look, your output is 0. So that is actually your 3-input Nand gate. 3-input Nand gate. Always remember, it is your 3-input Nand gate. Okay? When both, when all of your inputs are 0, no, when all of your inputs are 1, that time your output will be 0. Okay, that is actually Nand gate. A, B, C bar. Now, I understand that it looks too clumsy because when you have 3, 4, 5, 6, 7, 8 inputs, that time it will look very difficult. Okay, very difficult to understand. That's why from now on, if you draw in the software, you have to do this. You have to design all the wires. But when you design these in paper, that means when you design something in paper, that means for exam, right? For exam, when you design these in paper, you do not have to give these. Okay, no, not needed. So make it as simple as possible so that it is understandable. You do not need these, do not need these, do not need these. I do not need that. No need it.
Tadi rumah belaan ni macam kalau ayah tak ada ni. Ha apa dulu dia biar biar kau malu. Biar ayah kau supaya hak ilmu di sana ya Allah.
Okay, do not talk. Do not talk.
Allah. Ah bas kebar.
Now here, so when you have a design, when you have to do the design on paper, right? On paper, do not draw all the connections. Okay, do not draw all the connections. What you do, you just draw like this and indicate which one is your A, which one is your B, which one is your C, just like that. This is our A. So this is also our A. So indicate twice so that I will understand this one and this one, they are connected. Write B at the gate and write B here as well. So I will understand these two are connected. So when you connect, when you write C and write C here, so that time I will understand both of them are connected together. So this one look okay. By the way, you do not need an LED as well. Okay, you do not need an LED. Just give a line and write Y. Okay, on paper you do not need one LED. You just draw like this up to this. That will be your Y. And okay, let's remove it. So this will be your Y. Now always remember, you have to write VDD. You have to write VDD, or you have to give me the symbol, right? This one. So some people do not give me this symbol. Some people just write it like this. Okay, you have to give me the symbol like that, and you have to draw the ground. This is important. You have to draw the ground and you have to draw the VDD. If you do not do that, I will cut 1 mark. Remember, every time you miss it, I will give 1 mark. I will cut 1 mark. Okay. These are the things you have to understand. So you have to write these. This is actually your A, B, C bar. Now let's talk about AND gate. Okay. Let's talk about AND gate. So clear everything. Now, 1 minute. This is your A. This is A. This is B. This is B. So your output is actually what? Y is equal to AB bar, right? That was your output. This is NAND gate. But I want you to design an AND gate. AND gate, not NAND, AND gate. AND gate means your output will be AB, not AB bar. So how can you design that? We cannot design that by default, because your CMOS, I told you before, your CMOS will always give a bar at the output. So how to remove the bar? We have to remove it manually. So what we do, see, in our digital electronics class, we have learned this. What? If you have an NAND gate, that is this is your A, this is your B, your output will be AB bar, right? We knew it. Okay, your output will be AB bar. So if we connect one NOT gate at the output of the NAND gate, what will be our final output? Because we know NOT gate always connect, will always add one bar, right? So it will add 1 bar. Oh my God. It will add 1 bar on AB bar. So AB bar was already there. So now you will have 2 bar, right? So both of the bar will be cancel each other. If they cancel each other, so you will have AB. Okay. Double bar means cancel each other. Okay. So you have to connect one what? You have to connect one NOT gate at the last, or at the I should say at the end of your NAND gate. Otherwise, you will not get the AND gate. So let's try. Let's try. So we will take one. Now, can you see this? So this is your final result. What you have? You have A, B, A, B. So this is your NAND gate. Your NAND gate will give you AB bar. After that, you have a NOT gate. Then that will be double bar, because in your input you have AB bar. In your output you will have AB double bar. So that become AB. So this whole thing, the whole design, your whole design, this whole design is your AND gate now. Oh, by the way, I missed something there. And this is connected. Okay. So here, this is your A, this is your B. Now this A is connected here and here. This B is connected here and also here. Okay. So this is your A. This is your B. And this is your AB. So this is what you have inside one AND gate. This is what you have inside one AND gate. Always remember this, because we all know our logic circuits are made of transistors, right? Our CPUs are made of transistors. Our ICs are made of transistors. We all know it, all knew it before. But these are actually transistor. This one MOSFET is one transistor, right? You have 6 transistors here, not 6, 1, 2, 3, 4, 5, yeah, 6 transistors here. You have 6 transistors in 2 input AND gates. Understand? 2 input AND gates. Now, if I ask you to draw a 3 input AND gates, what will be the thing? So you will have one more NAND gate, one more NMOS, one more PMOS. That's it. And that will be connected. That will be called C, ABC. And your NOT gate will remain like this. NOT gate we will not have one more NMOS, one more PMOS in NOT gate. NOT gate is NOT gate. NOT gate is always like this. So when you do not have any bar, so shortcut. So one word, when you do not have any bar, no bar means you need to connect one NOT gate. There is a bar, no need. There is no bar, connect NOT gate. There is bar, no need. Remember. Understand? Have you understood?
Yes, sir. We get it.
Okay. Let's give 10 minutes of break. We will start again because আজকে আমাদের আর কোনো theory নাই. We do not have any more theory, any more lab. We will do that. We will make আমরা মাত্র কয়টা ইনপুটে গেলাম? We tried 3 inputs, right?
Yes.
We tried 3 inputs. After that, we will try to go to 6 inputs and custom logic unit. Custom means this one. See this. Custom means we will try to make like this. Y is equal to A, let's say B plus C
Bye.
let's say this one, A into B plus C bar D. Okay, we will try to design this sort of what is that expression today. Okay,
Okay, sir.
let's give 10 minutes of break.
স্যার আমার একটা কোশ্চেন ছিল স্যার।
বলো বলো
স্যার এই যে এইখানে স্যার মানে লাস্টটাতে ছিল ন্যান্ড গেট আর এন্ড গেট দিয়ে স্যার একটা 3 ইনপুটের ডিজাইনটা ন্যান্ড গেট আর 3টা এন্ড গেট ইউজ করছেন স্যার। সেখানে আমরা যদি স্যার ধরেন 3টা এন্ড গেট ইউজ করলাম আর একটা ন্যান্ড গেট ইউজ করলাম, সেটা দিয়ে তো করা যায় স্যার।
বুঝি নাই
মানে স্যার ওই যে স্যার ন্যান্ড গেট আর এন্ড গেট দিয়ে স্যার 3 ইনপুটের একটা ডিজাইন করতে বলছিলেন না স্যার একটু আগে স্যার? এটার আগে
আমি ওটা বলি না, আমি বলছি তোমাকে, আমি তো তোমাকে দুই ইনপুটের ন্যান্ড গেট ডিজাইনটা দেখাই দিলাম, তুমি 3 ইনপুটের ন্যান্ড গেট ডিজাইন করো, আমি এটা বলছি। ন্যান্ড গেট দিয়ে কিছু ডিজাইন করতে বলি নাই, ন্যান্ড গেট এন্ড গেট দিয়ে কিছু ডিজাইন করতে বলি নাই, আমি বলছি যে তুমি মসফেট দিয়ে মানে CMOS দিয়ে ডিজাইন করবা, ইউজিং CMOS। এখানে খেয়াল করে দেখো, তুমি এখানে খেয়াল করো, দিস পার্ট, এই যে এই পার্টটাই হচ্ছে আমাদের বেসিক্যালি একটা ন্যান্ড গেট। ওকে, এটি আমাদের ন্যান্ড গেট, এটা 2 ইনপুটের ন্যান্ড গেট, কারণ এই যে এটা একটা ইনপুট, এটা মানে এটা একটা ইনপুট। ওকে, এই যে এই দুটো কমন A, এই দুটো কমন, এরা হচ্ছে B, মানে এই যে এটা
জি স্যার
B, আর এরা কমন, এরা হচ্ছে A। দ্যাট মিন্স ইউ হ্যাভ 2 ইনপুটস, রাইট? সো তোমার যদি 3 ইনপুট থাকে তখন তোমার কি করতে হবে? তোমাকে এখানে আরেকটা লাগাইতে হবে, এখানে তোমাকে আরেকটা লাগাইতে হবে, ঠিক আছে? দ্যাটস ইট।
জি স্যার।
আর তোমাকে যদি এখন বলি যে 3 ইনপুটে NAND তো হয়ে গেছে, 3 ইনপুটে AND বানাও, ওই একই সাথে হচ্ছে যে তোমাকে লাগাইতে হবে, নাম কি, নট গেট লাগাতে হবে, ঠিক আছে? আরো যাক, হ্যাঁ আরো যাক, আরো বুঝতে পারবা। আমরা একটু পরে নর গেট শুরু করব, নর গেট, তারপরে আমরা চলে যাব হচ্ছে এই ডিজাইনে। ওকে,
আচ্ছা ঠিক আছে স্যার।